What happened before the Big Bang? It's a question that feels almost illegal to ask. We're taught that the Big Bang was the beginning of everything: space, time, all matter, and energy. So, how can there be a before? Well, some of the most brilliant minds in physics are tackling this very question, and their ideas are absolutely mind-bending. Let's start with what we know. About 13.8 billion years ago, our universe burst into existence from an incredibly hot, dense point called a singularity. From that moment, it started expanding and cooling, eventually forming the galaxies, stars, and planets we see today. This is the Big Bang Theory, and it's backed by overwhelming evidence, like the cosmic microwave background radiation, the faint afterglow of that initial explosion, and the fact that distant galaxies are all rushing away from us. But the theory has a problem: the singularity itself. Our current laws of physics, both Einstein's general relativity and quantum mechanics, break down at this point. They can't describe what a singularity is or what came before it. It's like trying to divide by zero. The math just doesn't work. This is where things get really interesting, because to go beyond the Big Bang, we need new physics. One of the most popular ideas comes from string theory. String theory suggests that the fundamental building blocks of the universe aren't point-like particles, but tiny, vibrating one-dimensional strings. This theory requires extra spatial dimensions beyond the three we experience. In one version of this, called the ekpyronic model, our universe is a three-dimensional brane, like a giant sheet, existing in a higher dimensional space. According to this model, there could be other branes floating around in this larger space. What we call the Big Bang might have been the result of two of these parallel universes, or branes, colliding. Imagine two massive sheets smacking into each other. The colossal energy from that collision would have been converted into the matter and energy of our universe, kickstarting its expansion. In this scenario, the Big Bang wasn't a beginning, but just a dramatic event in a much larger, older cosmos. Our universe could be just one of many, created in a cycle of brane collisions that has been happening forever. Then there's the Big Bounce idea, which comes from a theory called loop quantum gravity. This theory tries to merge general relativity and quantum mechanics. It says that spacetime itself is made of tiny, discrete loops or chunks, like pixels on a screen. There's a smallest possible size for these chunks, which means the universe could never have been an infinitely dense singularity. So, what does this mean for the Big Bang? Instead of a beginning from nothing, the Big Bounce suggests our universe came from the collapse of a previous universe. Picture a universe that expanded, then eventually, gravity pulled everything back together in a big crunch. But instead of collapsing into a singularity and ending, it reached a point of maximum density and then bounced back, re-emerging as our expanding universe. In this model, our Big Bang was actually a big bounce. Our universe could be just the latest in an eternal cycle of expansion and contraction, stretching infinitely into the past and future. It's a cosmic recycling program on the grandest possible scale. Another fascinating idea is the concept of a multiverse. This isn't just one theory, but a consequence of several different ones, including string theory and a model called eternal inflation. The inflation theory says that in the first fraction of a second after the Big Bang, the universe underwent an exponential, super-fast expansion. Eternal inflation takes this a step further. It suggests that while inflation stopped in our patch of the cosmos, allowing our universe to form, it continues in other regions, constantly spawning new bubble universes. Each of these bubble universes could have its own unique set of physical laws and constants. Some might be similar to ours, while others would be completely alien and inhospitable to life. In this view, our Big Bang wasn't the asterisk beginning, but simply a beginning the moment our particular bubble universe came into being within a vast, ever-growing multiverse. The question, what came before the Big Bang, becomes what is happening outside our universe right now. The multiverse is a truly staggering concept, suggesting that our entire cosmos is just one grain of sand on an infinite cosmic beach. So which of these ideas is right? the brain collision, the big bounce, or the eternal multiverse? The honest answer is, we don't know yet. These are theoretical frontiers. We can't directly observe what came before the Big Bang, but that doesn't mean it's pure guesswork. Scientists are looking for indirect evidence. For example, some theories predict specific patterns or scars in the cosmic microwave background radiation subtle temperature fluctuations that could be relics from a pre-Big Bang era. Projects like the Planck satellite and ground-based telescopes are mapping this ancient light with incredible precision, searching for clues. A faint, cold spot or a strange alignment in the CM could be the smoking gun that points to a collision with another universe or the echo of a previous cosmic bounce. The search is on, and every new piece of data gets us closer to an answer. But let's take a step back and consider something even more profound, championed by the late, great Stephen Hawking. He, along with James Hartle, proposed what's known as the no-boundary proposal. This idea uses quantum mechanics to describe the universe's origin. It suggests that if you go back in time, the distinction between space and time blurs. Time, as we know it, becomes just another dimension of space. Think of it like the South Pole on Earth. If you're at the South Pole, there's no direction that is south of you. Every direction is north. Similarly, in the no-boundary proposal, if you go back to the beginning of the universe, there is no before. The question itself becomes meaningless because time didn't exist in the way we understand it. The universe, according to this model, didn't have a beginning in time. It just is asterisk. It smoothly came into existence from a quantum state without a starting edge or boundary. So we have these incredible, competing pictures of our cosmic origins. Did our universe arise from a collision of higher dimensional brains? Is it the latest iteration in an endless cycle of bounces? Or is it just one bubble in an infinite sea of other universes? Or did it emerge from a state where time itself didn't exist? The quest to understand what happened before the Big Bang is one of the most fundamental challenges in all of science. It pushes the limits of our imagination and our technology. While we don't have a definitive answer, the journey itself is revealing a universe far stranger and more wonderful than we ever could have imagined. The Big Bang may not have been the beginning, but simply a doorway to the cosmos we inhabit today, with a history that could stretch back into eternity. Thanks for joining me on this journey to the edge of time. If you enjoyed this cosmic exploration, be sure to like this video and subscribe for more deep dives into the mysteries of the universe. See you next time.